In this video, we are going to talk about domain and range, what makes something a function, as well as intervals of increasing and decreasing, as well as intervals of constant. So the first thing we need to talk about is the domain. Now, the domain is our inputs of our function. It's our x values of the graph. Of the function. Our range are our outputs of our function, and our outputs are our y values of the graph of the function. Now, a function is a relation. So every type of equation is a relationship, whether it's a function or not, depends on whether the relationship where each input has one and only one output. So for what we call this is we say for each x value, there is only one y value. All right, so let's put some of these definitions into action. So first, we're going to try to decide if this function is a function or not, and we're going to use something called the vertical line test. And remember, a vertical line is a straight up and down line. So if I gave you a graph such as this one in red, I would use the vertical line test. I would draw a vertical line. I could draw multiple vertical lines. And I can see that it only hits the function once. So since it only hits the function once, then does it pass the vertical line test? Yes. So that means it's a function. Now they want to talk a little bit about what domain and range of this function would look like. So my domain is all the x values. So if I look at my left and my right, because we know left is negative infinity, right is positive infinity. We talked about this with our number lines. Although it looks like my arrows are going straight up, they're really going to the left. Really, this is going to get wider, 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 wider. This is going to get wider, 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 wider. So my domain is going to cover all the values. So my domain is going to be negative infinity to infinity. Now our range, we need to go from the bottom, the lowest point on our graph, to the highest point on our graph. Now, the lowest point on our graph actually has a point right here, and it sits at 0, and we're going to include it because there's a point there, and then it points up forever. And we know with y, if it points down, that's negative infinity, and if it points up, that's positive infinity. So my range would be 0 to infinity, positive infinity. All right, let's look at these functions that we have, and let's do our vertical line test as well as determine the domain and range. So similarly, this first function is going left and going right, and this is actually an absolute value function. So I can see that for my domain, this arrow is going towards negative infinity, this arrow is going towards positive infinity, so my domain is going to be negative infinity to infinity. For my range, the bottom is here, the top is here. So again, this bottom is sitting at 0, and the top is pointing towards positive infinity. And so let's see if this passes the vertical line test. So if I draw a vertical line, it does only hit once, and I can do it in a lot of places, only hits once. So yes, this is a function. All right, so let's look at this next one. If I draw a vertical line, I can see, oh, it hits twice, so no, this is not a function. So I'm not going to worry about my domain and range because it's not a function. Now let's look at this next one. Draw a vertical line, only hits once, so yes, this is a function. So I'm going to think about what my domain and range would be. So if I look at my graph, I know to the left is negative infinity and down is negative infinity. To the right and up are positive infinity. Since my arrow is going opposite directions, I know that my domain and range for any linear function is always going to be negative infinity to infinity. Because again, I always want to go left to right. All right, let's check this last graph. Oh man, hits the function twice, so no, not a function. Hits the relationship twice, so no, it's not a function. So I'm not going to worry about the domain and range. All right, so now we're going to review this in terms of a graph. So again, our domain is all of our x values. And we always want to go left to right. My range is all of my y values. And I want to go bottom to top. So we have two new words here. Intervals of increasing is where my graph, I'm going to put this in quotes, goes up from left to right. It's where my x's are increasing and my y's are increasing. First, if it's an interval of decreasing, this is where my graph goes down. But again, only when it goes down from left to right. So that means as my x's are getting bigger, my y's are actually getting smaller. And now a constant interval is when my graph stays the same from left to right. Or it's completely horizontal. So another tidbit about these is when we were talking about intervals of increasing, decreasing, or constant, we want to use our x values only to describe the intervals. And we will also only use parentheses. All right, so let's look at this graph. And let's talk about our domain and range. So again, our domain, we're going to go from left to right. So if I look on the left side of my graph, I can see that it starts here and stops here. So my domain is going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 11 to 11. And since they are filled in points, we can put the square brackets. My range is going to be bottom to top. So the lowest part my graph touches, so the lowest part of my graph is here at -2. The highest point of my graph is up here. So my domain would be -2 to 6. And it is square brackets because even though we don't see a big point there, there is a filled in circle there. All right, now I want to know where is my interval increasing. So if I'm reading the graph from left to right, if I look at this first piece, it's decreasing, then it increases, then it stops increasing, then it decreases, then it increases, and then it's constant. So the two places I highlighted in red are where it's increasing. And we're going to use the x value. So it increases from 1, 2, 3, 4, 5, 6, 7, -8 to -5.5. I guess So it's going to increase from -8 to -5.5. And then remember we use our union because it's going to increase from -2 to 4. All right, decreasing. So we said this first section is decreasing. Then it decreases again here. So those are the two sections where it's going to decrease. So it's going to decrease from -11 to -8, and then from -5.5 to -2. This last section here is constant. So from 4 to 11, it's constant. So under my constant, I'm going to say 4 to 11.